Hello students, I welcome you for the first PUC Computer Science class. As we know, we are there in Unit A, that is Fundamentals of Computer. In this unit, we are dealing with Chapter 3, that is Data Representation. In Chapter 3, that is Data Representation, we already gone through the introductory part, the non-positional number system, the positional number system, and in positional we have seen different types of number system, that is decimal, binary, octal, and hexadecimal. And at the same time, we learned to convert from one number system to another number system. From decimal to binary, octal, hexadecimal. Similarly, from binary to decimal, octal, hexadecimal. And from octal to decimal, binary, and hexadecimal. And hexadecimal to decimal, binary, octal. And then we studied in the last session the binary arithmetic, and in that, especially the binary addition and subtraction, we learnt it. Today's session I'm going to teach you, that is a representation of signed integer in the computer. We know in regular maths, the positive numbers, the negative numbers, how we represent. But in computer, how we are going to represent these signed numbers, that is what we are going to learn today's session. The other parts I'm going to discuss in the future, that is about binary subtraction using ones and twos complement, and binary codes, which is especially we call computer codes, that I'll discuss in the future sessions. So let me talk about more about a representation of signed integers. The digital computer handles both positive and negative integers. So as we day to day, all the number systems we are seeing, we require positive as well as negative. So in the computer also, we need to maintain positive as well as negative numbers. So we required for representing the sign of the number by using a negative sign or a positive sign. We make use of these two symbols to specify the number belongs to which type. Is it positive? Is it negative? So looking at the symbol, we will come to know the number is positive or a negative. If it is hyphen symbol comes, then we say it's a negative number. If it is cross symbol comes, that is a plus symbol what we say, then we call it as a positive numbers. In computer, usage of sign, it is not possible. That is the one drawback. We cannot make use of plus or minus symbol to represent any signed integers. So what is the alternative for representing integers? So that's what I'm going to tell you. So it is done by adding the leftmost bit to the number called sign bit. Now what do you know? You know in the computer all the numbers stored in the digital form, that is in the binary form. So as I told with you, in the binary we represent by using digits. Zeros and ones will be represented. So in the leftmost, that is what we are calling MSB. The leftmost one digit we are reserving for to represent a sign. For positive number, the sign bit value will be 0. For a negative number, the sign bit is 1. So this is the way in computer we can represent negative as well as positive numbers. So this is called fixed point representation. So this type of representation, what is the name of this representation, is a fixed point representation. Now, how we are representing the methods, what I am going to tell you people. The representing, we are using 3 ways are there. The first method is the sign and magnitude method. Sign and magnitude method. And the second method what we are using, which is proposed by our previously that engineers, that is one's complement method. And the third method is that is two's complement method. In these 3 ways in the computer, the positive and negative numbers they used to represent. Now this is what my dear students, we are going to learn in all these 3 methods how we can represent the negative numbers as well as positive numbers. Let us make a move to the next slide, which is I can give you more information about these methods one by one. So first let me take a sign magnitude method. Yeah. So let me take a simple number before going to this, that is 85 in decimal. What is there in binary? What is the value of 85 is there in binary? How we can convert? I had already taught you the conversion from decimal to binary. If you are good enough, you can write it directly. If you not, then make use of this method, right? So when you do this method, if you successively divide it by 2, and at the same time we are recording all the reminders in the right side. The first reminder we call it as a LSB, the last reminder if you call it as a MSB, and if you read from down to upwards, you will get the binary equivalent for the given decimal number. So that is what it's shown here. So when I've divided 85 by 2, I get 42 quotient, 1 reminder. Similarly 42 when I divide 21 quotient, 0 reminder. 21 when I divide by 2, 10 I'll get quotient, 1 reminder. Then 10 if I divide by 2, 5 quotient, 0 reminder. Then 5 if I divide by 2, 2 I'll get the quotient, 1 is reminder. Then again 2 if I divide it by 2, then 1 I'll get quotient, 0 reminder. Then again this one, if I divide by 2, 0 becomes a quotient and then 1 is reminder. So further we cannot divide. So that means we have to read from down to upwards. So 85 is in binary, it becomes 1 0 1 0 1 0 1. So this is the value. Okay. So this is what my dear students, this I'll take up with this number. I'll explain you the 3 methods, that is a sign and magnitude method, one's complement method and a two's complement method. So that's the reason I took 85. So 85 in binary, you note it down, 10 10 101. So this value you have to keep in remember. So let me move to the sign and magnitude method. So what is sign and magnitude method? So this is none other than fixed point representation. So I'll teach you. An integer containing a sign bit followed by magnitude bits are called sign magnitude method. Whichever integer you are representing in the computer, the first bit will be decides as a sign. If 0 means positive number, if it is 1 means negative number, and followed by the value will be there, whichever integer, so that is called magnitude. So such a type representation itself is called a sign magnitude integer. Now in this method, the first bit, that is what I said, MSB, is considered as a sign bit, and the remaining bits stands for magnitude. Yeah. Here positive number starts with the 0. Remember, positive number starts with the 0 value, that first bit value, and the negative number, that bit value becomes 1. Okay? Yeah. The computer size is 1 byte, then plus 85 and minus 85 represented in 8-bit sign magnitude method in this way. See, computer representation will be there. So how many bits it will take by the computer will say. So there are olden computers, they used to represent 4-bit, the first computer. Then came 8-bit, then came 16-bit. Now present is there 64-bit. Okay. So this is the way representation will be there. Now this is what I am going to teach you, 8-bit representation. That computer word I am telling. Word means the memory size. Word is there. So 1 byte, if it is say, that means 1 byte means how many bits will be there in 1 byte? 8 bits will be there. So 8 bits representation if I take, so then then the positive number, that is plus 85, how it is represented, see here. This is plus 85, right? Now here, there's a first bit. This is a bit is there. This is what I called sign bit. Okay, sign bit. Now here, this sides, this is 0 value is there. That means it is a positive number. As just now I wrote it in the binary number. In the previous slide, we have seen the 85 how we are representing 10, 10, 10. So this is called magnitude of 85. The magnitude means the 85 value in binary. Now this, what we say, computer treated as a plus 85 because the sign bit value is 0. Then how we are representing in the negative number? That is here. This is the way. Now here the minus 85 is there. So sign bit value is what is there now here? 1. So 1 means it is a negative number. The magnitude is same. See here, this is a 85 value. Correct, no? So similar way here also will be there 85 itself. 10, 10, 101. 10, 10, 101 means in decimal 85. So that is what I wrote here. So this is, my dear students, sign and magnitude method. So whichever number if they give, the first digit from the left side, that is MSB, if it is a 0 means that whatever magnitude value is there, that is there in positive. If it is first bit 1, that is MSB is 1, then whatever magnitude value is there, so that is negative digit, negative number. So this is a sign magnitude method. Yeah. Moving to the second negative number representation. Okay, that is ones complement representation, what we call. Yeah, so let me keep it in front of you. Ones complement method. Now before going to that, I just want to tell you what is ones complement. Complement. Yeah, so need to see how it is there. Yeah, I'll keep it in front of you. It is a simplest method of representing a negative binary number. It's the simplest method. Okay, and what it does here, the given binary number, we have to convert into the ones complement means what we have to do. So we are just changing 0 to 1 and 1 to 0. The given binary number digits are there. Each digit value will be there, either 0 or 1. In case if you want to take a 1's complement, so wherever 0 value is there you write 1, and wherever 1 value is there you write 0. Just flip from 0 to 1 and 1 to 0. So that number is called 1's complement. So that is a negative number in computer. This is a second method of representing negative number. The first method what we have seen, sign magnitude method. So this is a second method to represent a negative number. In other words, we change bit in the number to its complement. Complement we are doing. Okay. Complement means no, we are changing the state from 0 to 1 or 1 to 0. So we are changing the state in each bit. The binary digit is called bit. So in each bit we are changing the state itself called complement. Example. Now we'll see what is the 1's complement of the given number. This is in 8-bit format it is there. Okay. So this value is 85 itself. This value is 85 in decimal. So what is the complement of this? The complement of this is we are changing the bit. This is in positive it is there. The given number is positive. Got it? The 1's complement what you are taking, just we are changing. Where 1 is there becomes 0. Where 0 is there 1. So where 1 is there 0, 0, 1. So we just flipped. Correct? No? In every place we shifted. Now this is what happened. It is represented in a negative number. See here the starting digit is 1. So that means it is there in negative. But whereas in the sign magnitude method, the magnitude doesn't change. Only sign bit is to change. But here entire number will change. Entire number will change. We are taking 1's complement. So therefore, the negative number, the plus 85 is there here 0, 1, 0, 1, 0, 1, 0, 1. But when we go for 1's complement, that means in the computer it is treated as a negative number. That means 1, 0, 1, 0, 1, 0, 1, 0. So this is a negative number inside the computer. Okay, because computer doesn't know. Computer doesn't know. We know because we are humans. We are looking at the symbol, the front prefix symbol will be there. Either plus symbol will be there or minus symbol will be there. Looking at that, we will decide this is a negative number, this is a positive number. Now, how computer will come to know? Computer we have to specify, right? Okay, it's a machine, right? So machine will treat it in this system. Okay, so the starting bit it's seen here 1 is there. So that means it is a negative number, and this is what we know to represent in another method, that's the 1's complement method. We're just flipping the digits. Got it? So this is called as a 1's complement representation. Yeah. So I think you understood the sign magnitude. Sign magnitude only we are first digit we are changing, the most significant bit, starting leftmost bit. 0 if it is a positive number, 1 is there means negative number. The magnitude value will not be changed. But in 1's complement what it happens, it will change us. Okay, we are flipping. Yes, going for another method, the third method. The third method is 2's complement representation. The third method is 2's complement representation. Okay. Now what here its specialty is there? We will see. The 2's complement of binary number is obtained by taking 1's complement of the given number and adding 1 to the least significant bit, that is LSB. If you add 1, then that binary number is there in 2's complement. What you have to do? First, the given binary number, what you have to do? Take a ones complement. Ones complement, how will you take? Just flip the digits. Okay, 0 to 1, 1 to 0 you are doing. Then what you have to do? You have to add 1 at LSB. Last digit in the is there, no? That means rightmost digit you have to add 1. So that becomes 2's complement. The general procedure to find 2's complement is given. This is the way. So let me show you here. That is 2's complement equal to 1's complement plus 1. 2's complement means take a 1's complement and add 1. Yeah. So now I'll show you the same for the given 85. Yeah. Now this is a 85 values there in binary 0 1 0 1 0 1 0 1. Correct, no? The positive number, it is represented in this is the way, the plus 85. That is 0 1 0 1 0 1 0 1. There is no changes. The starting bit is 0. That means it is positive number. Now how we are doing in negative number minus 85? How we are representing? So that becomes 1 0 1 0 1 0 1 1. Now how I got this? See here. This is given number. Now I have taken 1's complement here. What I did? I have just flipped. See here 1 it was there. It becomes 0. 0 to 1. 1 to 0. 0 to 1. 1 to 0. 0 to 1. 1 to 0. 0 to 1. Right? And then add 1. Last add 1. Added. So this 0 plus 1. 1. Then this is 1 as it is. 0 is there. 1 is there. As it is, rest is there. So this itself this. So this is 2's complement. This is 2's complement. So this is another way the negative number represented in the computer. Okay. So we learned here 3 methods to representing negative numbers in the computer. Now you don't have any confusion. Okay. So you are learned till 10th standard to represent positive numbers and negative numbers by using signs. Now you are grown up, you are learning how computer works, right? So in the computer, the positive number represented as it is, the negative number we can represent in 3 ways. The first one is sign and magnitude method. The second way is 1's complement method, and the third is 2's complement method. So whichever suitable, that method you can make use of to store negative numbers inside the computer. Yeah. Now I'll brief you how this 3 method works, which is very suitable for the computer, and which is now in these days which method they are using. Let me keep it in front of you. Now I'll just perform one small calculation by using all 3 methods. So which suits the method, you can inform me or you can decide yourself, right? Yeah. Now let me take up here. Now in reality, in decimal, plus 85 minus 85, if you add, what you get answer? If you add plus 85 and minus 85, you get 0. Correct, no? Everybody knows that. Okay, we learned it and we know how it becomes 0. If you add a positive number with the negative number of same value, then result comes 0. This is known truth. Now, in case if you are going for sign magnitude method, the sign magnitude method, the 85 is representing the positive, 85 it is represented in this is the way. The start bit is 0, that means positive. Then 1 0 1 0 1 0 1. Correct, no? The negative number is represented, which we have seen in the last line. Okay, how I got that? go to the previous a little rewind the video and just you can see that how it represented in sign magnitude. Okay, so that negative number, that is minus 85, we can represent in sign magnitude in this the way. The start bit becomes minus number, no? So 1 value is 1, so represent negative number, and the rest as it is there 1 0 1 0 1 0 1. If you add together, I have taught you in the last session binary addition. So 1 plus 1, what I get? 1 0, 0 I wrote, 1 went as a carry. Now here carry came. 1 plus 0 plus 0, what becomes? 1 itself. Correct? Next again, 1 plus 1, 1 0 it becomes. 1 goes as a carry, 0 we wrote here. Okay. Now 1 plus 0 plus 0, what it becomes? 1. Yeah. So again same way, 1 plus 1 I did, 1 0, 0 I wrote, 1 as went as a carry. Now again this is I added, 1 plus 0 plus 0, this became 1. Now again here I added, 1 plus 1 I added, it becomes 1 0, 0 I wrote, and 1 became as a carry. Okay. Now this 1 plus 1 plus 0 is there. So 1 plus 0 plus 1 is there. If I add, it becomes 0. So I wrote here. Now here I cannot add. So this becomes as a carry. This becomes end carry, what we say. Yeah, which is I rounded, no? This becomes end carry. This is in the sign magnitude method. Now if you go to the ones complement method, how it comes? Ones complement method. See the given positive number, same as they here say, sign magnitude also same representation. In the ones complement also same representation, the given positive number. Yeah, so that is plus 85. Here also 0 1 0 1 0 1 0 1 is there. In ones complement also 0 1 0 1 0 1 0 1 is there. Now minus 85, how we are representing in the ones complement method? That is, we are just flipping the given number. So 1 means 0 it became, 0 means 1 became, 1 means 0. We just flipped all the digits. Yeah, which is I just now taught you people. So it is there. This means minus 85. So this means plus 85. Now we'll add this also. Now 1 plus 0, what I got? I got 1. 0 plus 1, I got 1. 1 plus 0, I got 1. 0 plus 1, I got 1. 1 plus 0, I got 1. 0 plus 1, I got 1. 1 plus 0, I got 1. 0 plus 1, I got 1. So that means here all the digits become 1. Correct, no? All the digit becomes 1. Now we'll go for a 2's complement method. How it works? 2's complement method. So let me show you in the 2's complement method. So when you see in the 2's complement method, see this given 85 in the positive as it is there. Okay, same way, similar way of what one's complement and sign magnitude method is there. Same way, 0 1 0 1 0 1 0 1 it is there. But how do you represent in 2's complement method? So we are just flipping and then we are adding 1. So according to that, we get 1 0 1 0 1 0 1 1. This is what we have learned. Correct, no? Now this is there minus 85. This minus 85 is there in 2's complement. How computer represent? Now if this we add it together, if we add it together, what happens? 1 plus 1, what becomes? 0. Correct, no? And 1 goes as a carry. Again, 1 plus 0 plus 1, what it becomes? 1 0. Okay, 0 we wrote here, 1 becomes carry. Now 1 plus 1 plus 0, what answer comes? 1 0. So we wrote 0 here, 1 becomes again carry. Now here 1 plus 0 plus 1, what answer comes? 1 0. We wrote 0 here, 1 went as a carry. And again if you do that is addition, 1 plus 1 plus 0, we get 0, 1 goes as a carry. 1 plus 0 plus 1, we get answer is 1 0. So 0 we wrote here, 1 went as a carry. And then 1 plus 1 plus 0 when we do, we get answer is 1 0, and 0 we wrote here, and 1 went as a carry. Again to addition, 1 plus 0 plus 1, we got 1 0, 0 we wrote, and no more addition digits are there. So this 1 becomes as a end carry. This 1 became as a end carry. So this is what my dear students, you get answers when you do addition with the different signs of same value. Okay, so according to that, which is answer is what answer comes in decimal as right. Okay, now this is actually we should get 0, but what is the answer we got here? So normally computer what it does, the end carry, no, it will discard it, because we have treated number is in 8 bits. Only 8 bit considers, the 9th bit, whatever extra bit comes, no, it will be discarded. Computer what it does, discards. Okay, so this one and this one is discarded. Okay, so according to this, what we get answer is the one is discarded, is it disappeared. Now this means 0 0 1 0 0 1 0 means the starting bit what it is there, 0. So that means number is there in what is the answer here, positive. So what we got answer is 42, plus 42 we got. Okay, now if you see here also, this is C, number is there in negative. So number if it is there in negative means no, this is 1's complement. 1's complement is there. Okay, if you take a 1's complement, what you get answer is, it's 0. It's, you get minus 0. You get minus 0. Okay, now the third one is there. Now here all the 0 is there, this is 0. Okay, looking at this method, my dear students, the first one, the sign magnitude gives wrong answer. Okay, sign magnitude method gives wrong answer. But 1's complement gives answer is 0, but for 0 it gives negative sign. In reality, for 0 there is no sign. We learned very well. For 0 we don't put any sign. 0 is neutral. It is not positive number or it is not a negative number. It's a neutral. But if you refer 1's complement method, then for 0 minus symbol comes. Yeah. And 2's complement, if you see, correct answer came. What we are getting regular answer, no? Same answer gets. So that means looking at this calculation, we find 2's complement is a suits here. 2's complement method is a suits here. So let me give you one more example to make you still more clear. See here. Let me take a first number, that is plus 95. And second number, same I'll take minus 85. If you add together, what answer should come for you? 10. You should get answer is 10. Let us see, if you refer sign magnitude method, what answer you get. So in sign magnitude method, this is what comes. For plus 95, when you write, this is starting bit is 0, this means positive number. This 1 0 1 1 1 1 1, it is a magnitude for 95. Okay, for 95 magnitude is there, 1 0 1 1 1 1 1. And what is for minus 85 we represent in sign magnitude method, that is starting bit is negative, minus 1 is there, rest 1 0 1 0 1 0 1. So same as what you have seen up, no, same idea. Now this add together, what you get? Addition we know. 1 plus 1 we get 1 0, 0 I wrote, carry went here. Now 1 plus 1 plus 0 when we do, we get 1 0, 0 I wrote, carry I took here. Now 1 plus 1, we get 1 1, I wrote 1 here, 1 is went as a carry, I wrote it here. 1 plus 1 plus 0 I wrote. I got answer 1 0. So I got 0 I wrote here. 1 I took as a carry. 1 plus 1 plus 1 I did addition. Then I got 1 1. Then 1 I wrote here. 1 I took as a carry. 1 plus 0 I did. So I got answer is 1 itself. I wrote here. So no carry generated here. Now next is 1 plus 1 is there. I got answer is 1 0. 0 I wrote here. 1 generated carry. So I wrote here. Now here 1 plus 1 I did. I got 0. 1 0 I answer got. I wrote 0 here. And 1 I generated as a end carry. This is end carry. So I got answer is 0 0 1 1 0 1 0 0. This is in sign magnitude. Let us see in 1's complement. In 1's complement, this is the way it comes. This is 95, we are represent same year here. And minus 85 in 1's complement, whatever you are written here, no, same as here comes here. So that is, we are just flipping the given 85, 10, 10, 10, 10, 5. Now if you add this, what I get answer? If we add this, what I get answer? See here. Now 1 plus 0, what I'll get? 1 itself. Correct, no? This I get 1. Here 1 plus 1 is there. I get to answer is 1 0. 0 I wrote. I got carry and I wrote it here. So here when adding with the carry with these two numbers, the 1 plus 1 plus 0 when you do, I get again 1 0. 0 I wrote here. And 1 carry generated, I took it here. Now here 1 plus 1 plus 1, 3 ones are there. After adding 3 ones, I get 1 1. I wrote 1 here and 1 carry generated, I took it here. Now 1 plus 1 plus 0 I did. So 1 0 I got answer. 0 I wrote here, 1 I took as a carry. Now here 1 plus 0 plus 1 I added. So here I got answer is 1 0. And 0 I wrote, 1 I took as a carry. Here also I am doing 1 plus 1 plus 0 when I did. I got 1 0. 0 I wrote and 1 I took as a carry. Here also 1 plus 0 plus 1 I did. So answer I got 1 0. 0 I wrote, 1 I took as a end carry. 1 I took as a end carry. Got it? Yeah. So this is what I got answer here. 0 0 0 0 1 0 0 1 in 1's complement method. So let us see what we get in 2's complement method. Yeah. So 2's complement method also I wrote the 95 as it is. I wrote what we have taken up in sign magnitude method in 1's complement method, that is 0 1 0 1 1 1 1 1. And minus 85 I took it in the 2's complement method. The same I took it here down. So how I am doing that minus 85 representing I have taught you. So that value is 10 10 10 11 I got. Correct. So let us do the addition. So 1 plus 1 what I get? 1 0. 0 I wrote here. 1 I took it as a carry. Here I wrote. So now here I am adding 1 plus 1 plus 1. So 3 ones are there. I get answer is 1 1. So 1 I wrote here, 1 I took as a carry. Now here when I am adding 1 plus 1 plus 0 when I am adding, I get answer is 1 0. I wrote 0 here, 1 took as a carry. Now when I am adding 3 ones, 1 plus 1 plus 1, I am getting answer is 1 1. So 1 I wrote here, I took as a 1 as a carry here. Now here 1 plus 1 plus 0 when I am doing, I get answer is 1 0. 0 I wrote, 1 I took as a carry. Again when I am doing adding here, 1 plus 0 plus 1, so I will get 1 0. 1 I took as a carry, 0 I wrote here. Now when I am performing again addition here, 1 plus 1 plus 0, I get 1 0 answer, 0 I wrote here, 1 I took as a carry. Now here 1 plus 0 plus 1 when I am doing, I get 1 0, 0 I wrote here, and 1 I took as a end carry. The last carry as I treated as a end carry. In all three addition, in the sign magnet method also, 1's complement method also, in 2's complement method also, we got end carry generated. Yeah? Yeah. And after generating here, what is the answer? It comes here 0, 0, 0, 0, 1, 0, 1, 0. Okay, this is the answer what we got. So according to the law of computer, the end carry what we generated now, we have to discard. I discarded end carry. See here, whatever I marked in circle now, it disappeared. Now what is the answer? See, all in three cases, the starting bit you see. Here also 0 is there, here also 0 is there, here also 0 is there. That means answer is there in positive. The starting bit you see. Correct, no? Answer is there in positive. Now, when it is there in decimal, when I'll see, this means plus 52. This translating value, what it comes? Plus 52. In reality, what should I get? Plus 10. But I am getting plus 52. What it means? This is wrong. This is wrong. Second, in 1's complement, when you see, I get plus 9. In reality, what should I get? Plus 10. But I am getting plus 9. So this method also not suits. In third method, that is 2's complement, what I am getting? I am getting plus 10. So this is what in reality what you are getting in regular addition. So I got 10. So this is the same. So this means, my dear students, even though we are representing the negative numbers in computer in three ways, that is in sign magnitude, 1's complement as well as in 2's complement, but when you are going for an operations like addition or subtraction, the 2's complement method suits rather than other two methods. That is the reason all modern computers operate based on 2's complement representation. The all modern computers works based on 2's complement, all this. So this is the basic idea, my dear students. That's the reason I taught you all the three methods, but we should know all the three methods. But which is suits for today's computers? That is 2's complement representation. You have understood, I think. So dear students, I can understand it is very easy to teach you people through online. I'm showing this slide beautifully and with put some little bit color and everything I'm showing. But to make sure that you have to understand properly means no, you have to work out. Just looking at the video and if you sit quiet, doesn't work out. Don't be bothered about textbook. Don't be bothered about what notes you have to write. Bother about what you have to do. So what you have to do, take up simple other numbers, translate into the binary and try to convert into all the sign magnitude method, 1's complement method, 2's complement method, and try to perform these operations. What you get, you see. What you get, you see. See, you properly try to understand what is binary addition, binary subtraction, and the representation of negative numbers in the computer, and make use of that operations. Only when if you do lots of operations, then you'll understand, my dear students. Okay. So with this, I conclude this session here. So that is about representation of negative numbers in computers. I will teach you in the coming session how can we perform subtraction by using 1's complement method, by using 2's complement method. Till then, take care. A great ahead for you and enjoy your day. May God bless you.